Hello everyone, this is Neha, and in this lecture we are going to cover some important topics which are useful in troubleshooting electronic circuits. So let's begin with this topic, choosing a resistor of a circuit, and this topic has been picked up from the Group's Electronics book, and this tells how to pick a resistor for your circuit. So the first step is to determine the required resistance value, and that you can determine by using the Ohm's law. So this is R is equals to V by I, where R is your resistance, V is the voltage, and I is the current. So if you know these two values, you can determine the value of the resistance, and then calculate the power dissipated by that resistance using any of the power formulas. So you might be familiar with the formula P is equals to V squared by R. So using that formula, you can calculate the power, and based on that, select a wattage rating of the resistor that will provide an adequate cushion between the actual power dissipation and the resistor's power rating. Next is the maximum working voltage rating. So this maximum working voltage rating can be defined as the maximum voltage which a resistor can withstand without any internal arcing. And this maximum working voltage rating can be defined from wattage rating. So higher the wattage rating of the resistor, then you will get the higher will be your maximum working voltage rating. So here maximum working voltage rating is continued, and you see this formula. This has basically formed from the same formula which I told you previously, which is P is equals to V squared by R. So P is the power, where V is the voltage and R is the resistance. So it's derived from there. And V max in this formula is your maximum working voltage rating. And if you see that this is the square of V max is directly proportional to the resistance. So if you have a large resistance value, then your maximum working voltage rating will exceed. Okay, so that's the formula you can use to calculate the resistance, and if you have to calculate the working voltage, then in that case you need to know the resistance value and the power rating. Now next is electric shock. So when you're building the circuit, make sure that you're building the circuit based on the schematic provided by the manufacturer, or you have enough knowledge about the circuit you're building. Okay, make sure that there are no wires hanging out, and which could be dangerous or may produce any shock. So there should be no wires hanging out like that, and then when you build the circuit, your power must be shut off. Okay, and once the circuit is completed, then only you should start doing the measurement. And when you are measuring the voltage, then it is advisable to measure it by one hand. Otherwise, the high voltage can get into your body. And keep yourself insulated from the earth ground, and that will protect you from any electric shock. Hand-to-hand shocks can be very dangerous because the current in that case can flow through your heart, and that will not be good for you. And so make sure that you don't do that. Now next is ground connections in electrical and electronic systems. It is important to have a ground connection when you're building the circuit, and ground connection is nothing. It's basically goes to the equipotential surface, which is your earth, and earth has, at any point on the earth, the potential is zero, which is basically your voltage is zero. So how that's possible? Because you can assume earth has a copper ball, and anything connected to that ball has basically zero resistance. So if the resistance is zero, then whatever how large is your current is, that is going to be that will make your voltage is equals to zero, because V is equals to IR, and R is virtually zero on the Earth's potential. And if R is 0 multiplied with current, V is equals to IR, then that will produce your 0 volts. So thus all points connected to earth ground are at same potential, and 0 volts is the most convenient value we use for earth ground. And then it says here the most electrical electronic system, one side of the voltage source is connected to the ground. So that you already know, you have been building a lot of circuits which has the ground, and now you know what the ground is, and how the voltage goes equals to 0, because the resistance is virtually 0. So here is this shows several schematic ground symbols. So these are the different symbols you can use. So this is earth ground, which is a chassis and common form of equipotential node, but not as big as earth. And this one is chassis ground, and it means the equipotential surface formed by equipment is chassis, which is usually aluminum. And if chassis ground is connected to earth ground, then entire chassis is connected to 0 volts earth ground. Okay. And then you have a common ground. Common ground is used in electronics many times, and it means a common interconnection node or a bus in the circuit, usually on the PCB. If you work on PCB, you will see this is grounded, and it's usually formed by a single flat solder trace with many branches. When you see the PCB, you will get to know how this common ground is made. So ground is assumed to have a potential of 0 volts regardless of schematic symbols shown. So yes, for all three of them, the potential is going to be 0 volts. These symbols are sometimes used inconsistently with their definitions. However, these symbols always represents a common return path for current in a given circuit. So this was your different schematic ground symbols. Now moving on to the next. Next we have the voltage measured with respect to ground. So when a circuit has a ground as a common return, measure the voltage with respect to ground. So this you have been doing many times in your circuit, measuring the voltage with respect to ground. For example, in your op-amp, or if you're measuring the output voltage from the transistor. So in both the cases, so let's maybe first talk about the op-amps. You always measure the output voltage in inverting and non-inverting op-amp with respect to ground. So that's how you measure the voltage with respect to ground. And same in the transistor also. If you're measuring the voltage across the collector, then also you measure with respect to the ground. Now next we have ground connection in electrical and electronic system is continued actually here, and the two circuits are provided in this slide. And the first circuit, you see that ground has been mentioned in this way. This is the ground symbol, and in this the negative side of this total VT voltage is basically grounded, and all these voltages you see here, V1, V2, V3, they are all positive with respect to the ground. So with respect to the ground, you see at this potential this is a positive voltage, at this potential with respect to ground this is 20 volts, and then this is 30 volts. Whereas in this particular circuit, your VT total voltage is you see here, this is the positive side and this is the negative side. So the positive side of this voltage is grounded, okay. And all these voltages V1, V2, V3, they are all negative with respect to the ground. So you see that this is negative voltage with respect to ground, and this is negative voltage with respect to ground. So if you measure this circuit, then you'll get these voltages, voltage levels. So this was your ground connection. Now next is AC signal characteristics review, and here you see the AC signal. We are going to briefly cover the important points in the signal. So this signal which you see here is the same signal over here, and this complete cycle is called your period, and or you can say the repeating signal can be characterized by a period t, and signal which do not repeat, they don't have a period, or they don't have the frequency. So this time period is your t, and frequency is given by f is equals to 1 by t, 1 by time period. And there's one more term called duty cycle. Cycle of any signal is the percentage of time the signal is high. So that's your high voltage stage. And then in this particular signal, we have this is called your peak value. And from positive to negative, this total positive peak to negative peak is called your peak to peak value. Or you can say, and this is also called your amplitude, and this tells you how big the signal is. And average value of the signal is basically calculated for half cycle, because if you consider the full cycle, if you want to calculate the average for the full cycle, then it's going to be 0, because this is same here and then this is same in the opposite direction, so the average value will be cancelled out. So that's why you always calculate for the half cycle, and average value time interval for this particular case is from this 0 to pi. And this picture which you see here is just a rotation of a motor, and it tells like at what angle, at what position the rotor rotates represents the angle. So this is the 0 volts. So 0 position 90 degree, it is in this vertical direction, and then it is like this in further rotation, which is at that point you have the 180 degree, because this motor has turned half, did the 180 degree rotation, or you can say from here to here it did the 180 degree rotation. So that's here half cycle, and then when it rotates from 180 degree to here 360 degree, or you can say 0 degree, then you have this negative half cycle. So, and that's how this whole cycle from 0 to 360 degree is your one cycle, or your one time period, and frequency is 1 by this time period. So that's a basic review of the AC signal. And there is a quick question for you all. What is the easiest measurement to make? A voltage, a current, or a resistance? So in that case, voltage is easier to measure compared to other two, because in the voltage measurement, you just leave the equipment power on, and you place the voltmeter leads across the 2 points in the circuit to make a measurement. Whereas in case of current measurement, you have to disconnect the circuit by first turning off the power and then disconnecting the circuit wherever you want to measure the current, and then you connect the ammeter and you do the measurement of the current, and then you turn on the power and then you do the measurement. So that's the long process. So compared to that, measuring the voltage is much easy. And in case of resistance, there are equipments available where you can directly measure the resistance, and sometimes you have to take the resistance off and then you measure the resistance. So yeah, that's all for today. Thank you so much for watching.